Right, question 11. An arithmetic series has n terms, all of which are integers. The sum of the series is 20. Which of the following statements must be true? Okay, so let's have a look. Well, it says must be true, right? So, we could just make up random examples, right? If we see a counterexample, then great, right? Then I can straight away cross out some of the options. So let's make up some random series, all right, such that the sum is 20. Any ideas? So what I have in my head is that, first of all, when you construct a series for a certain sum, right, you think of an average, first of all. So what do I mean by that? For example, if 20, you could think of it as, for example, 4 times 5, right, that's 20. So what does that mean? So if I have an average or mean of 4, and I have 5 terms, then they will add up to 20, right? Because if 5 numbers have a mean of 4, then surely their sum is 20. Make sense? So how can I make this? Well, the mean is 4, right? Okay, and I'm just going to extend on both sides, right? I need 5 terms, so I'm going to go, doesn't matter, 2, 3, 4, 5, 6, for example, right? There's 5 terms, and this is perfectly symmetrical, so the mean is 4, right? So the sum must be 20. You can check, right? 2 plus 3 plus 4 plus 5 plus 6 is indeed 20. So how many terms does this have? 5 terms, right? So option 2, gone, right? N is not even, right? N is 5, so N is odd. Okay, how about option 3? The common difference is even. Well, the common difference is 1, right? So 3 is also wrong. Okay, how about option 1? Can we cross that out? The first term of a series is even. Okay, we can't quite cross that out yet, right? Because, what do I want to say? Because there's 2, right? I mean, because, there's an example there, right? It's not a counterexample. Good. Okay, so let's try to find some counterexamples to option 1 then. So what can we do? Let's have a think. We could think of something like, let's say 2 times 10, for example. Is that possible? Let's have a look. So, let's say I have an average of 2, and I have 10 terms. Is that possible? Well, not quite, right? Because you sort of want an odd number of terms, right? Because you can't expand on both sides of the spectrum, right? Okay, so let's try to find an example. You just give it a go, and you get negative 1, 3, 7, 11, for example. You can try lots of random things, right? And this works. This works, right? Because then the first term of the series is odd, right? Negative 1 is odd, right? So option 1 is also wrong, right? I mean, you can be more naive than myself, right? You could just go negative 3 and 23, for example. This is an arithmetic series, right? It's just that it only has 2 terms, for example, and this is okay, right? A series does not need to have lots of terms. Right? You can have only 2 terms. That's also perfectly fine. Okay, so you don't need as complicated as an example as myself. All right, just find something as easy as negative 3 and 23, which adds up to 20. All right, so none of them must be true. So option A.